everyone, welcome back. In this particular video, we will be discussing the problem class representative. So let's just directly jump onto the problem statement, that is milestone number 1. The sports teacher told the students of a class to assemble in the playground. Okay, so there are some students which will be assembled in the ground. The order in which the students are standing in the ground is given in an array where each element of the array represents the height of the student. That is, there will be array. Let's say array name is height or nums, whatever it is. So in each value of this nums array, there will be height of a particular student assigned in the line. Rahul, the class leader, is asked to check if the heights of students are it monotonic, but only at even positions are they monotonic. That is, given at indices 0, given at index 2, 4, 6, 8, given at even indices 0, 2, 4 indices. Are the students ordered in monotonic order? Are their heights in monotonic order? What is monotonic order? It is either in non-decreasing order or non-increasing order. Now, what is non-decreasing, non-increasing? That is also important. So that we will discuss later on, but you can assume that we have to check for the input array at even indices whether the input array is monotonic or not. Say increasing if the students at even position are standing in non-decreasing order. Else say decreasing if the students are even positions are standing in non-increasing order. Else say none. Now, what actually is non-decreasing, non-increasing? We know what is increasing, but what is non-decreasing? Non-decreasing order is nothing but, example is 1, 1, 2, 3, 4, 4. So as you can see in this order, we have all the values. Either the current value is same as the previous value, like 1 is same as 1, 2 is more than 1, 3 is more than 2, 4 is more than 3, 4 is equal to 4. Either the current value is same as the previous value or the current value is greater than the previous value. So in such a thing where the order is either we are same, either the value is constant or increasing, either constant or increasing, either constant or increasing, something like this, either in constant or increasing. This kind of graph is known as non-decreasing graph. Why? Because either it is increasing or it is same. So it is not decreasing. That's why it is known as non-decreasing. What will be non-increasing? Obviously, the graph which will not increase, that will be non-increasing. That is, either it will decrease or it will remain same. So this will be your non-decreasing graph. Actually, non-increasing graph, not non-decreasing, non-increasing graph. That is the graph, the array where the values are not increasing, either remaining same or decreasing. Example can be 10, 10, then maybe 5, 5, then maybe 3, then maybe 2, 2. This kind of graph where either the values are same as the previous value or smaller than the previous value. So we have to check whether the array values only present at even indices are non-decreasing, non-increasing, or none of them. So there can be different test cases. Let's just directly jump onto the sample test case 1, where we are having array containing 6 values and the values are 12, 65, 15, and so on. So let me just bring this array into the notes and we will discuss about that whether it is non-increasing, non-decreasing, or what. So if I write the indices, this is 0th index, first index, second index, third index, fourth index, fifth index. For now, in the problem statement, it is mentioned just only compare for even indices. So we can ignore the values at odd indices. That is, we can just directly jump from even index to even index. Now, what is the order? As you can see, there is 12, then there is 15, then there is 19. 12, then there is 15, then there is 19. So it is actually non-decreasing. Non-decreasing, why? Because either it is same or it is increasing. Actually, there is no same value, but it is only increasing in nature. So output is increasing only. If it will be non-decreasing, output increasing. Similarly, for one more test case, if I am giving 6 values, the values are, let's say, or maybe not 6, let's take 10 values this time. The values are 1, 2, 2, then 2 again, then let's take 3, then let's take 3, 4, 4, 4, 5, 6, 6, 6. How many values I have taken? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's take this much only. Let's ignore all of these 6. So we have array of 10 size. And I have taken some repeated values. But as you can see, at even indices only I have to figure out 0, 2, 4, 6, 8. In these indices, what can you see? From 1 to 2, increasing. From 2 to 3, increasing. From 3 to 4, increasing. From 4 to again 4, same. So again, it is non-decreasing. So what should be the output for non-decreasing? The output for non-decreasing should be increasing only. The output is increasing, but although we say it is non-decreasing, actually both are the one and the same thing. It is just that two values can also be same. But other way around, if I will take other way around, that is just inverse this array itself. What will happen? There are 10 values, 5, 5, 5, let's take, then 4, 4, 4, 4, then let's take 3, 3, 2, 2, 2. So how many values I have taken? 3, 3 and 4, 7, 8, 9, 10. So I have already taken, I guess, more than 10 values. So what is the order in this? If we talk about the even indices, 0, 2, 4, 6, 8. So from 5 to 5, same. 5 to 4 decreasing, 4 to 4 decreasing, 4 to 3, actually 4 to 4 same, and then 4 to 3 decreasing. So either same or decreasing, it means non-increasing. And for this input, what should be the output? The output should be decreasing only. For this, we have to print decreasing. But there is one more case. If there is either increasing or decreasing, then print increasing or decreasing respectively. But if it is none of them, neither increasing nor decreasing, then we have to print none, I guess. Then we have to print what? We have to print none. So that can be a case also. Let's take, there are 10 values only. Values are 5, 5, 5, 4, 4, 4, then 6, 6, 6, then maybe 8, 8, 8. If this is the array, actually there are more than 10 values. There are 3, 6, 9, 12, 12 values. But whatever is the case, if we talk about the even indices only, we have to only compare for even indices, whether it is monotonic or not. So both the arrays which are increasing or decreasing, they are known as monotonic. But will this array at even indices, will it be monotonic? From 5 to 5, same. From 5 to 4, decreasing. From 4 to 6, increasing. Now, at one point of time, it is decreasing. At one point of time, it is increasing. So it can't be only non-increasing or non-decreasing. Is it non-increasing? No, it can't be non-increasing because it is decreasing. Because we are saying that it is increasing, it is non-increasing. No, because it is decreasing, can we say it is non-decreasing? No. So both of the points are eliminated. So it is else. We can say it is none. So what you have to do is, as you can see in the approach itself, just compare the two adjacent values in terms of even indices. That is, compare the second index with the 0th index, 4th index with second index, 6th index value with 4th index value. Just compare these two values, the adjacent values in terms of even indices, whether the order is increasing. If it is increasing, eliminate the option non-increasing. That is, mark the the non-increasing option as false. Similarly, if there is a decreasing nature, if the array of I is more than array of I minus 2, 6 was more than 4, then we have to eliminate non-increasing. Similarly, if array of I is less than array of I minus 2, eliminate the option of non-decreasing. Because if the value is decreasing, how can it be non-decreasing? If the value is increasing, how can it be non-increasing? So just eliminate them. And finally, we can check whether the option of non-increasing is eliminated or not, whether the option of non-decreasing is eliminated or not. If I will go back to the same test case, we can say initially both the options will be true. We can say non-increasing option will be true. Initially, obviously it is non-increasing, non-decreasing, both are correct. Both are correct. And we will say 2 is more than 1. It is increasing in nature. If it is increasing, non-increasing will become false because it is increasing. 3 is more than 2. Increasing, so it is already false. Increasing, already false. Same, don't do anything. So finally, as you can see, non-increasing is false, but non-decreasing is true. Non-decreasing means we have to print increasing. It is slightly different in terms of output, slightly confusing in terms of output, but just figure out non-increasing versus non-decreasing. That will be easier. Similarly, for this test case, initially non-increasing will be true, as well as non-decreasing will also be true. Both will be true. 5 is equal to 5. We can't eliminate any option. Equal does not eliminate, because equal can be non-increasing as well as non-decreasing. So for equal, don't do anything. 4 is less than 5. So if it is decreasing, non-decreasing will be false, because non-decreasing, it is not there. It is actually decreasing. 4 is equal to 4. So can't do anything. 3 is less than 4. So again, just eliminate non-decreasing. So finally, we are saying that since non-increasing is true, output will be decreasing. Output will be decreasing. What about the last case? In this last case where we were printing null, initially both of the options will be true. Non-increasing will be true. Non-decreasing will be true. We will say 5 is equal to 5, no need to do anything. 4 is less than 5, decreasing, so mark this as false. 6 is more than 4, increasing, mark this as false. And if we are both having false, so output none if both the options are false. So this will be the approach which will take how much time complexity? Since we are going to run a loop over all the even indices of the array, it will take order of n by 2 elements time. That is, it will run a loop on the half size of the array, but we can say it is linear in nature. So time complexity will be linear. What about the space complexity? Since we are not going to take any extra space, only two variables, Boolean variables, bool, true or false variables will be used. We can say space will be constant in nature. So let's now actually do the third milestone, which is writing the instruction manual. What we are going to say? Set two Boolean variables. Set two Boolean variables, which are nothing but non-decreasing and non-increasing as true initially. Non-increasing and non-decreasing as true. Once we have set these two variables, what we have to do? We have to run a loop over the even indices and starting from second index, because we will be comparing the current index with current index minus 2, the previous index, which is even index previously. So we will run a loop, a for loop, we can say, over all indices, over all even indices actually, over all even indices from 2 till n minus 1 by jumping by 2, because even indices means jump by 2 by plus 2 gap, by 2 gaps. And every time what we have to do, whatever the index we are getting, we will compare this index value with the index minus 2 value. If we are saying nums of index, if num of index is more than num of index minus 2, if it is increasing, num of index is more than index minus 2, it means it is increasing. Now current value is more than the previous value, so mark the non-increasing false, mark non-increasing as false. Similarly, we have to check one more thing. If num of index is less than num of index minus 2, then the current value is smaller than previous value. So mark non-decreasing as false. And we don't have to do if else if, we only have to do if. Even if you want to do if else if, you can do it, but better will be just check for whether it is increasing. So mark this as false. Whether it is decreasing, mark this as false. And now finally, what we have to do? When do we have to return increasing? When the even positions are non-decreasing, it means non-decreasing is true. So if non-decreasing after the loop is it true, then return a string, print a string increasing. When do we have to print decreasing? In the other way around, that is if non-increasing will be true. If non-increasing is a true, then just what? Do what? Just return decreasing. And if it is none of them, then we have to return what? We have to return none. We have to return a string containing none. So this will be the instruction manual for the problem class representative. So let's just directly use the instruction manual in order to write the code. What we have to do? We have to maintain two Boolean variables. So Boolean non-increasing, is it true initially? As well as non-decreasing, is it true initially? Both variables will be true. And we can't use this kind of nomenclature. We should use this kind of nomenclature, non-increasing, non-decreasing. Now we have to run a loop over all the even indices. That is, index will start from 0. No, we have to start from second index, so that we can compare with the previous index minus 2. So start from second index, go till less than n, and do the jump by 2, as it is mentioned, by 2 gap. And every time what we have to do, compare the current value with the index minus 2 value. If the current value is more than the index minus 2 value, if num of index is more than num of index minus 2, then just mark the non-increasing as false. That is, we can't have non-increasing now because it is increasing. Similarly, if decreasing is false, if num of index is less than num of index minus 2, we can't have non-decreasing. In this case, mark non-decreasing as false. So we will say non-decreasing is false. And once the entire loop is done, we are getting two variables, either true, false. So we can say if the non-decreasing variable is true, then answer is increasing. Then we have to print increasing. So return increase in strength. Similarly, if non-increasing is true, in this case we can say since it is not increasing, obviously it is decreasing. So print decreasing. And if it is none of them, then we have to print none of it. So return none. So let us run for three types of test cases.
So if I will run the code, let's see what is the output which we are getting. Are we getting the same output for the sample test case or not? And as you can see, it is giving me increasing for this array 12, then 15, then 19. So it is 12, 15, 19 increasing only. But if I will take the opposite, that is if I will take, let's say instead of 19, if I take maybe only 10, so it should give me none. It is not increasing as well as it is not decreasing. So ideally the output should be none. Let's wait for the code to run and it is giving me none. So let's submit it and see if all the test cases are passing or not. And it is taking some time to run. Let's wait for it. It is showing that all the 13 test cases are getting accepted. What is the time complexity of this approach? See, we are having a loop over all the even indices. So at max, there can be n by 2 even indices. And in such a case, the loop will be running for n by 2 times. That is order of linear time complexity. But what about the extra space? Since we are having only two variables, Boolean variables, non-decreasing, non-increasing, one byte usually. So it will be constant extra space. So linear time, constant space solution we are having. And with that, actually, we are done with the problem class representative. We will meet with a new problem in a new video. Till then, bye bye, take care, keep coding, and keep up.